Hi, everybody, and welcome to Build Meets World. We are joined today by a good friend of mine, Wei Lam. Hi, Wei.
Hello, Marcy. How are you?
Very good. Thanks for joining me today. We put this broadcast together hoping we'd be more in person with each other and not virtually connected. But I know I missed you this week while in Boston. I was only there for a short time. I tried to twist your arm to come out to the Black Rose, but it just wouldn't work, right?
It's a busy time, Marcy. Busy time.
Exactly. Well, thank you for joining me today. I love this ability to connect with people like yourself all across the country here and talking about things that we love, this industry and performance, right? Do you remember where we met? I'm putting you on the spot.
Oh shoot. Where we met? I no, it's been too long and I'm too old. So no.
I I used that yesterday. I was doing a demo because now I'm down in Florida and I was doing a demo and I'm like, I'm too old for this. You guys go do that. So
Yeah. So where
it,
was
it
it?
It was a building science camp. I think was the first time we officially met up in Wexford.
Yeah.
And I just throw that out there because I think, when I think of someone like yourself and the friendship that we have, it's based on the passion we have for the industry. So I just want to say I appreciate your
What
friendship and our ability to connect through the years. So
this the same, Marcy. And you've certainly stayed in touch better than I have. And the where we met, that venue in particular, is really telling of
yeah.
a lot of the industry, right? How much passion there is in the industry, and it's a great place to develop friendships just like this one.
Exactly. Yeah, it's good. I always tease, however, hopefully no one from my company is listening. Like if I wasn't approved to go, I would go on my own just
Right.
because that's how valuable I think it is. So hopefully no one's listening from my company. But and I'm happy to say I think it's happening again this year. So we
It
share
is.
that
That's the rumor on the street. Yep.
absolutely. Well, speaking of summer camp and you, I know you are in Boston. Have you always lived in Boston?
Not always. After I graduated from the University of Massachusetts, I moved out to Seattle for about 10 years, and hit it right at the height of the leaky condo crisis as a young engineer. And so that's where I sort of cut my teeth on building science and building technology.
Well, and it's an unfortunate way to cut your teeth, but what a great way to cut your teeth, right? Like
Uh,
I feel there's no better way than the don'ts that we see out there to really help us learn what not to do.
And there's a real evolution that happened there. I mean, I remember I was just looking at I was digging through my basement last weekend, looking at drawings that I had produced, back in the late '90s as part of that first job out there in Seattle and fixing leaky condos. And the materials that we were using then, it's evolved, well, I guess a lifetime or a career time, if you will, since then, and quite a bit more technology. Available today than there was at that time.
Oh yeah. Well, and that's what really I think makes things like building science camp or our conversation so critical, right? Because they are constantly evolving and changing. I was talking to a builder down here in Florida yesterday, and he was very proud to say that he was 68 years old and he didn't want to miss the opportunity to come out and learn what we were showing him yesterday, because he wants to make sure that he understands the of course the features of different types of new products, but also the limitations, right? What do
Sure.
we not do, or what do we want to be cautious about when we install these systems? So it was just so refreshing chatting with him. And he it was so funny because he walked in, and you know how you kind of like prejudge somebody, he's sitting there all around, and I was like, I'm looking at my content, and he came over to me, he goes, I hope you're going to talk a lot about, like vapor control and the thermal barriers of building. And I was like, I love you. So
That's great, Marcy. It reminds me, I was just going to say, the sort of initial reaction you had, or maybe judgment that you passed, and thinking about all the contractors and other professionals that I've encountered over the years that have said, well, I've been doing this for 30 years, and I'm just thinking, like, I'm coming up to 30 years pretty soon here. I'm going to be that guy pretty soon, and but I think that there's been a lot more openness. To learning and understanding that the technology has evolved significantly, and doing sort of business as usual, or the way we've done things for the last 20 or 30 years is going to require some real requires some real innovation and forward thinking to solve some of the the bigger challenges that we have with our buildings, existing and new.
Well, and a big shout out to you and your experience, and of course all the work that RDH does in terms of not only testing and evaluating different systems and conditions, but also the technical resources that you guys put out in support of what you're learning. So that obviously those are the efforts that are really helping us as an industry, for sure.
Well, I appreciate that, Marcy. And, I would say, it takes a village, right? It takes manufacturers, consultants, all sorts, right? Academia to sort of contribute to this sort of forward motion. So, but I appreciate that. Thanks.
Absolutely. So as I mentioned, obviously you are our guest contributor today, working with RDH, and I snagged not only your picture, but I loved your other landscape picture there. Tell me what's going on in this picture here.
Well, I had an opportunity there was a precondition or pre-sale condition at the John Hancock. I don't think it's called the John Hancock Tower anymore. It's the tallest building in Boston. It was designed by I.M. Pei and was affectionately known as the Plywood Palace for some time in the 70s. This is the glass tower in downtown Boston. But I had an opportunity to get to the top of that building, and what you see on the left there is just a photo of the in-house rig system that runs around the perimeter of that building. And there is no parapet, right? So you can walk right up to the edge of that building and look straight down 60 stories. But this is, a view of the Boston skyline, at least looking sort of west into Cambridge and down the Charles River. So it was a unique opportunity to get a cool shot.
Yeah, and that's what I love, that while we're working, we get these unique opportunities, to capture, especially Boston, the city where you are working in every day. So it's a pretty cool picture. Had to include that. So, as we talk about all these different things, I know it's very important to you in your role. You're working with all aspects of design, right? So from the specification all the way to commissioning. Is there a certain aspect of what you do every day that you feel needs the most attention? I know that's kind of putting you on the spot, but if you had one, like, I wish we could focus more here when we look at how we're building today.
I think there's a lot of focus on various building technologies, and the things that we can be doing to improve the efficiency and performance of our buildings. But there's a lot of I'm just going to say unsexy things, right? And I think we're going to talk. We are going to talk a little bit about air barriers, I think, and some of these technologies are sort of, you don't see them, you don't smell them, you're not aware that they're there and performing a really important function.
Yeah.
And getting teams, design teams, contractors, any of the stakeholders in a project to recognize the importance of some of these components. And, I mentioned air barriers, but there's lots of other things that need to be considered that are sort of fall in that same camp. And oftentimes early engagement into a project, right? That's really where we're focused right now, is getting the opportunity to engage. It doesn't have to be a lot of work or recommendations or effort, but just getting people to start thinking about how these materials and systems are going to be ultimately integrated into a building. So that has to do with chemical compatibility. It has to do with construction sequence. Can you get these materials in at the right time? And in the right place. So, I would say, to answer your question, it's really about early engagement and also understanding the material limitations, right? What are the limitations of these materials?
Well, and I love how you said that, because getting people together as early as possible is going to save everybody a lot of time and a lot of cost, right, associated with changes later versus changes in the beginning. So I really do. I love that, and I think we can't communicate too much, right? But like you said, it doesn't have to be a lot. We're not talking about hours of communication. It's just kind of getting together with what we can to get that conversation started.
Yep.
As you mentioned, today we are talking specifically about air barriers. I do a lot of training for air barriers because there's not the ASTM guide spec. Like for the area that we work and play in with Tremco, we have sealants, coatings, waterproofing, fire stopping, gaskets, glazing, like all these different products that we go back to the AS team guide spec for to say, okay, here's my property testing, and here's the values that I should achieve. And that's how the, you know, the spec writer, whoever it is, kind of looks at comparing them. It doesn't exist for these products, right? And lots of products can act like an air barrier, and that's why we need to look at these 4 things, and that's what I constantly talk about. So a couple weeks ago, we talked about air impermeability. Last week, we talked about continuity. Today, we want to focus on structural integrity. What do you think, like, what comes to mind when you think structural integrity of this air barrier?
Well, you know, if you think about it, you know, I talk a lot about, you know, primary seals or the plane of air tightness. And, you know, if you think about this, the air barrier should be the most airtight component in your wall assembly. And as such, it's going to be subject to the pressure differentials between inside and outside, right? So structural integrity, one of the first things I think about is that you may be, it needs to be able to resist the full pressure difference across that wall. That's, you know, and that might be as a result of wind, stack effect, or mechanical pressurization, right? So you have to think about, you know, whether that's going to happen. And if it, you know, so that's the first thing. The second thing is just, you know, what are the conditions, you know, in the at the site, and what are the implications of membranes or materials that need to span different kinds of different area, you know, different conditions on the project.
Yeah, no, those are excellent points. And I think, you know, as we look at these requirements specifically, I noted a couple things, which is right in line to what you're talking about, right? And people think structural, they think that's something to do with structure, right? It's really about those negative and positive pressures, as you mentioned, being able to withstand. And you mentioned it earlier as well, you know, it's the stuff behind the facade, right? So we can't get to it. People, like, when I would talk to my friends about what I do, and I'm like, what I do, you can't see, but it's protecting the building, right? It's like, you know, the inside
Right.
of your jacket, you know, the meat of your jacket and what it has to do. And that's what's scary, because we can't go back and maintain it, right? You can't lift up that facade and see how things are doing, right? So it gets pretty scary.
You can, but it's usually pretty costly and you know, highly disruptive to, you know, to occupants.
Yeah. So I just put a, you know, just a couple pictures up here. Goes right along with what we're talking about here in terms of testing and performance. So these are just a couple notes that I always ask, you know, what about adhesion testing? What about system testing? And not only for air, but water too. Any comments about that as it relates
You know,
to all this?
I would say adhesion testing, you know, I think there's a, you know, a large part of my career has been focused on, you know, getting enough knowledge around the materials, you know, that are just coming at us. You know, there's a new, like, some days I feel like there's a new material coming at us, you know, every day, right? There's a new material coming at us every day, and understanding how these materials interact, whether or not an air barrier adheres, you know, adheres well initially and over time, right? Making those evaluations. And I think it's very difficult if you're not sort of entrenched in the industry to understand, you know, what are the chemical makeups of these materials? You know, are there classes that we can look at to say, well, this is going to work with this and this isn't going to work with this? Having that knowledge is incredibly important. And, you know, I think, as you know, just even 150 years ago, there was a very small, you know, even 100 years ago, there was a much smaller sort of library of materials. And today it's almost, you know, infinite, right? You know, you don't know what you're going to encounter on a project, or what a team may have already identified as materials. So understanding classes of materials, but also very specific qualities and characteristics of particular materials is increasingly important, so that you don't have to engage in testing on every project, because it's not, you know, that's not something that every project has the time or budget or you know, the possibility of.
We just got a question in based on, you mentioned new technologies coming at us on a regular basis. How do you feel about something that's new? Hey, Wei Lam, here you go. Here's a brand new technology. Would you like to try it?
Absolutely. Send me some, and, you know, I'm going to smell it. I'm going to taste it. I'm going to, you know, pull on it. But, you know, unlikely that I'm going to specify it on a project straight out of the gate, right? And I think as a consultant, and an engineer, we're somewhat cautious about new materials. We want to understand, is it, sometimes these new materials are simply rebranded, or private labeled from someone else, and we know exactly what the material is and maybe what the performance over time. In other cases, they're brand new formulations or new assemblies of materials, and we don't know quite what the long-term performance looks like. I mean, you can look at a number of industries, or not industries, but within our own industry, materials that have undergone formulation changes, have been pulled off the market for time, reformulated or modified in some way. And so we want to be, we are cautious of that. We tend to be conservative in that way. We don't, I think I'm not alone in saying we don't like our clients to be guinea pigs, for those types of products.
Well, and I like what you said about, getting it in your hand, touching it, smelling it, pulling on it, right? You do want that personal time with it to kind of see, based on your experience, what it looks like, how it's going to perform. Is there specific things that you want to see as well in terms of history? Like, obviously what we call it is like field trials, right? So we'll do handling trials. We want to make sure it handles similarly. And that's in addition to like all your R&D testing, your system testing, all that stuff. But then we go and do field trials, and we want to get that history going, right? Like on a job here, on a job there. Are all those things important, obviously, to you as well, to kind of see some of that history or where it's going or where it's been?
Absolutely. I mean, I take every opportunity, and certainly, with the team we have here in Boston, and really, this is I think a firm-wide approach too, is, understand how the contractors feel, the installers feel about these materials, because it might be the perfect material on paper. It might have, the ultimate performance, right? Everything that you want out of an air barrier or whatever it is. But if the contractors and the installers really find it, difficult to install, or it has some, significant limitations in storage or prep or whatever it is, it's not going to gain broad acceptance, and you're going to find it's going to be a difficult product when it's in a specification to actually get it to go forward. So getting that feedback, all the way from academia to the folks that are installing it is really critical to the success of a product. And I'm not talking about selling product. I'm talking about, is the product going to be installed the way it was intended to be installed? Because if it's not going to perform the way it was intended to perform.
Excellent points. And it's interesting because it's like, who's the customer we're focusing on? Which customer type? Yes, all of them, right? We need all of those different perspectives in order to make sure we've got something that can be installed, consistently installed, making sure people understand points of concerns, and then of course performance, and when what impacts performance from an installation or environment. So awesome.
Yep.
Awesome.
Yep.
So we've got a couple things here that I put together to kind of help us go through the conversation. I think we've touched on a lot of them already, but we'll just kind of zip through some of these here. These are the 6 I put together for now in the evolving conversation about air barriers. And like you said, even more than the air barrier, how that whole wall performs, right? We're going to talk about each of these here. So we got exposure, thickness, compatibility, adhesion, fire resistance, and then I just throw connectivity, which can mean a whole heck of a lot of things.
Sure. Mm-hmm.
And I love these pictures here because this is pictures. I taught a class when I was in Boston, that my colleague David Hutchinson's putting together, with vocational students. And I put these pictures up for them, and they were like, is that building being put up or taken down? And what are we seeing, right? And it's just so great to talk to someone with these fresh minds that don't have this level of experience. And I'm like, actually, it's going up. And they're like, well, what are we looking at? I'm like, this is what's behind what you see. It's behind that facade. So it's great how you were explaining that. It's behind the facade, just giving you some examples of what we need to make sure we look at from an exposure or performance perspective. So right. First up is exposure. And as we tie it back to structural integrity, which is our focus, right? What are your thoughts on exposure?
Well, I mean, certainly, I was at a project last week, and we were walking around, and we saw a large area with fluid applied air barrier, And we didn't see any installers or any activity around that the area. And I went up and I touched it, and it wasn't cured. And my first question was, when was this installed? And they said, oh, yesterday or maybe the day before. And I was thinking, well, this is not good, right? It's not cured. I mean, people are, there was other activity going by this area. And it so happened that the rep was there, and I asked him. I said, what's the deal? He said, well, it's just, it's too humid, right? It's just been too humid, and it's not curing. It's going to take some time, probably another day. And I think about, well, what does that mean, right? Is the material, so my question immediately was, is the material going to be okay in this, in this condition? Is it going to cross-link? Is it going to do the thing, chemistry-wise, the things that it needs to do in a time frame that means that the product's going to be, is going to perform as intended over time? And I got good assurance there. But it reminded me of other projects. Some projects I worked on in Seattle, where the conditions were not, this was some time ago now. Conditions were not favorable for curing of these fluid applied materials, right? They weren't cross-linking properly, so you had to tear the whole thing out and put it back, right? We looked at elongation and elasticity of these materials after they were installed and found no, that they hadn't developed, the curing hadn't developed properly. So there's that exposure, and then there's the whole other side, which is even if the material is installed properly, given logistics of construction materials this day and age, given the sequence, some panelized and volumetric or modular volumetric modular construction we're seeing. Some of these materials are, the manufacturers, the installers, the stakeholders want these materials to be exposed for long periods of time, right? That's the plan. And sometimes that exceeds 60, 80, even 90 days, well beyond that. So, understanding what the exposure conditions are and whether these materials can, are going to perform the way they were intended to perform over that time period after being exposed is critical.
You mentioned exposure, and obviously that was a great story, and I'm glad the manufacturer was there to kind of help you talk through, and I think that's the key part of it, right? So we're all there together. From an exposure perspective, the question that's coming in is there something specific you want to see? If I say this can handle 6 months, what would you like to see so that it can handle 6 months?
Well, I think that we'd certainly like to see some testing, right? That demonstrates that, right? And that's simple exposure testing. I think you talk to any building scientist or building enclosure consultant. I mean, they've all taken a piece of material somewhere and thrown it up on their roof and said, all right, I'm going to come back in 6 months and look at it. So, I think that is really critical. Of course, we'd like to see some consistency or uniformity between those testing, right? So if there's an ASTM that says, look, here's the test. And I think that consistency just helps compare materials, right? Certainly other products and systems in our industry have been established that way, right? Their performance has been established by a standard test method, so that you can make some comparison. And so I think that is important to see that. But certainly, the kind of testing that a manufacturer might do more informally, that also is very informative. Helps inform our decisions, right? And of course, the kind of work that we do, we throw all sorts of things up on roofs and monitor them over time.
Good. So I think I like that because we do both, right? Obviously, there's going to be some ASTM standards we follow, but if you're in an environmental chamber with different types of UV, is it UVA, UVB? Like we can throw all these questions, but what is it really going to do in Texas or Seattle, right? So that's why I think we try to do both. We try to do your lab tests and then do some exposure testing too, so we can say, oh, okay, this is what it's going to look like, or this is what the comparison is. And we always take something that's known as a control that we can compare it to, right?
Yeah.
Such as, but
yeah. So, Marcy, I just would add to that, I would say that, from, if the question, what I would say is, if manufacturers could be more clear about that kind of information, right? More upfront. Sometimes it's buried and you got to really go and look for it. And, as a consultant, I'll dig and I'll read and but as a contractor that's on, on site and, you're pressed, right? The material's showing up, you got to install it. Are you really paying attention? Is the information readily available? Is it easy to access, right? I need to know that I can leave this material out for 90 days. So I think, making that information more accessible and obvious would be, something that could, I've seen improvements on, of course, but I think could only be better.
That's great. Yeah, no, it shouldn't be buried.
Right.
It should be a treasure hunt for you to find it. So that's good. Next up here is thickness. Now I put thickness up here. I guess it's really kind of lens to technology, but the thought-provoking photos I'm showing you is like, we'll do tensile strength, right? Of a dog bone of material. We've got the bubble gun up there going, looking at different anchors. We've got a variety of different detailing of anchors. We've got a microscopic image of what we're doing when we look at like a concrete surface profile and how well the material gets into the nooks and crannies and so on. What do you think about thickness or technology?
Well, when we talk about air barriers and thickness, I mean, we know we can get good air barriers with, just gypsum, right? Just an air barrier. But does it, and there's a good reason why, an industry has developed around materials, membranes, and whether they're fluid applied, sheet goods, roll goods, about providing air barriers in a separate component, because we need them to sort of double duty in some ways, right? Oftentimes, right? It's not just about providing resistance to air movement, but it's also weatherization, right? Managing moisture behind a rain screen system or just a cladding system. And so when I think about thickness, I think about what is the double duty? What does it need to be doing? It's providing a barrier. And there's many air barriers out there that can perform quite well as air barriers, in a test situation or in an optimal situation at very thin, at very thin coating dimensions. But what are all the other things we're asking them to do, right? We need them to be, easily handled by installers, right? So, something that's super thin in a sheet or roll, not necessarily that easy to handle, right? So that thickness can contribute to handling. It's also got to be durable, right? So and sort of meet the the sort of demands on a typical construction site or new or existing building site. So thickness, and it's got to provide characteristics in terms of elongation and elasticity. So you gain some of that through thickness, but I look carefully at what the thickness requirements are and whether they have there's a practical reason for it. Certainly. In buildups of the buildups we're talking about are very thin. So it really is about what is the material makeup, a fluid applied versus a sheet good. There are multiple components in a sheet good, obviously, right? There's a carrier sheet, and then there's the adhesive, and maybe there's a reinforcing component. There may be a reinforcing component. So that in itself inherently means the product's going to be a little bit thicker, 40, 60 mils, something like that. Fluid applieds, I think, are a little different. And, I've seen manufacturers say, well, it's not unusual that you can read the sheathing board manufacturer's name through our coating. And, I think, well, is that the gauge that we're using, right, for thickness in fluid applieds? And again, I think it's guidance and understanding and education for installers that thickness, what is the thickness, and is it a rule of thumb? Are you going to look for the substrate manufacturer's name behind it? You've got to cover that up, or are you going to use methods to evaluate dry film or wet film thickness, right? How are you evaluating thickness? So that's kind of what I think about when I think about thickness of those types of barriers.
Well, and we got a couple questions that came in about, is there a preferred thickness? And I think you answered it. I don't want to answer for you, but I think what you're saying is a preferred thickness based on what you need, right? What your performance criteria is probably better stated, right? You're looking at like I think you said the thickness and why is it that thick? And then what kind of performance can I get thinking about durability and exposure and adhesion and compatibility and all those other things. So
Yep.
did I that
Yeah,
correct?
I think that's right. I think that's right, Marcy. And in large part, I mean, we will look for materials that have, I think adequate track record, and that the manufacturer has conveyed what those minimum thickness requirements are. And we do put some stock into the work that the R&D that manufacturers have done in developing their products, and also the criteria that they've developed. So if a manufacturer comes back and says, look, the application needs to be 30 mils, right? 30 wet mils. We'll look to that in the field, and we'll make sure the contractor understands how to measure that, and also the importance.
Well, and I like that whole performance conversation, because I know I've talked to Dr. Straub about this in the past, and he was like, not everyone drives the Mercedes, right? He goes, when do you need to pull out the Mercedes, or when do you need to pull out that performance? That's what we're looking at. And I think that's important from a building. When I was talking to these guys yesterday, they were like, all like, well, I'm building with this anchoring system, or I have this many stories. And I'm like, all those things are so important as you choose what system's going to work best for you, right? And what you might want in Florida is probably going to be different than what you're going to choose in Seattle or Boston. So
That's
awesome.
right. Yeah. And I'm certainly in no position to disagree with my good colleague, Dr. Straub. So yes, absolutely.
Well, I think the funny part of when he said, he goes, not everyone needs the Mercedes. We're looking at what is needed for that project. And then we went to lunch in his Mercedes. I think he had a Mercedes.
I actually don't know anymore, but he may well have a Mercedes.
But it was just, he's funny. I love his approach to things for sure. As we're kind of getting close to time, I know we talked about adhesion already. Compatibility is huge. We'll get to this point here is fire. And that probably is not something we can talk about in a few minutes. But when you look at something from a fire resistance perspective, like what comes to mind that you want to share?
What's coming to mind right now is just NFPA 285, right? Thinking about, how much, at least, in the last decade, how much confusion there has been around NFPA 285, the code requirements, and understanding whether these materials, air barriers in particular, in assemblies, really, perform adequately behind various types of cladding materials. And certainly there's been some very tragic fires in the last decade, where folks have talked about the combustibility of materials that are embedded into these systems, right? Whether that's been the insulation or other materials. So, we certainly think about that. And this gets back to sort of this idea of how many materials there are out there right now, how many materials we're thinking about in combination with, how many different types of combinations, right? It's not just load-bearing masonry anymore, right? A very small, a small library of materials. We're talking about a combination of infinite materials, right? And do they work together? Do they perform together? So, I think when we look at sort of novel systems, or, we're being asked to look at sort of something unique, or innovative, I mean, it's one of the first questions on our list, right? Does this work from a fire performance perspective for the intended use?
Yeah.
And I think the class of materials that we consider fairly typical right now for air barriers, we have a pretty good understanding of what works together. But I would say that there's a lot of technology still being developed, and we're going to have those questions, certainly into the foreseeable future.
Yeah, no, and I love that, because I think there's been some confusion. There's been lots of opportunities to learn more about it, and I think this still is. I hate saying a hot topic because of what it is, but it is, and I love that ability to continue to have conversations as it relates to this, because it does have that life safety component. When I was teaching these kids, though, they were like, they got that fire was important, but they were like, but that building could leak air every day, and that was something I've been teaching people about, like, we need to look at all of these things. And I think that's that holistic approach that you keep mentioning.
Yep.
So just to kind of close us off, I have this last slide here, and I think it's funny. It's almost like we planned this, and we didn't. But how many connections are we making, right? There's so many different connections coming together on these projects, not only with different types of air barrier materials, backup walls, insulation, and facades, what are your final thoughts as we close today as it relates to this?
I mean, this is, I think this is the crux of our work, right? This tends to be the focus of our work. How do we transition and terminate these kinds of materials to, all of the types of conditions that we might face on a project? Even in the design phase, identifying what all these potential conditions may be, right? We certainly see drawings now that, can go into a great deal of detail, and we can cut models and see conditions that previously was very difficult, right? When we were just working with printed drawings, right? Asking for more information took time. Now we can see them, right? But it doesn't necessarily tell the whole story when we can just sort of go into a model and sort of make some educated guesses or assumptions about what materials are going to need to be connected or transitioned. And it's becoming, as designs become more complex, as the tools that allow designers to make more complex building geometries and do, I'm going to say crazier things with our buildings, it becomes much more important for us to identify what those transition conditions are going to be and what's actually going to work. And some of these conditions are, brand new. I would say in the last month, I've looked at some conditions. I've said, I've never seen anything. How are we going to do this, right? And so working together with installers, manufacturers, other consultants that may be specifying those adjacent conditions, really understanding how it's all going to come together from a compatibility and both a compatibility and sequence perspective.
Well, and I like that, because I think your point all along is that collaboration needs to happen, right? As things get more and more complex, the connectivity is going to continue to get even more complex. So one final question for you, putting you on the spot. The question just came in. We always talk about connections, and I'm gonna ask you what you think is the most difficult. And do you think it's the roof to wall, the window to wall, the below grade to wall, or just like different types of penetrations all over the wall?
That's a difficult question to answer because we see it all, and I can say the condition I'm thinking of right now is really a window to wall interface condition, where the perimeter of that fenestration system is particularly complex, given the way it's anchored back to the anchored back to the rough opening, and how you get those components to be continuous. And I think the challenge with with fenestration in particular is that you potentially have a lot of different trades intersecting on one particular area, and getting the coordination and the sequence right is one challenge. But then also, if you think about all the types of sealants and other materials those various contractors and installers may be using, you have to understand are these materials compatible? What's the movement, what's the expected movement range, differential movement range between those materials? So that's, I think, fenestration, in particular, custom unitized curtain wall, can sometimes be very challenging at parapet, at termination conditions, right? Either punched openings or, sorry, not punched openings, but parapet conditions. So roof to wall, where the curtain wall, custom unitized curtain wall may run by the floor plate or the roof line.
So yes, yes to all, but yeah, no, I get it. And I think that's just, it goes back to what we've been saying: adhesion, compatibility, cooperation, and talking as early as possible. One of the things I noticed that you had on your LinkedIn was performance-based detailing. And I love that, because I think, yeah, we need to think holistically, but if the detailing doesn't work all along the way, we're not going to get that holistic approach. So I love that. I love that comment. Well, Wei, thank you for joining me today. This has been great. Super helpful to have this conversation. Hope to have many more of these in the future as we continue to look at different ways that we need to make these connections on our buildings. And whether it's new construction or restoration, there'll be things for us to talk about. That's for sure.
Absolutely. Thanks so much for the opportunity, Marcy. Always really nice to catch up with you.
Thank you so much. So everybody, if you want more information from the great technical resources of RDH, you can go right to their website and look through their expansive technical library. Lots of great information to share there. And as always, if you want to join in the conversation with any of us, just email me at mtyler@tremcoinc.com, and we'd be happy to have you on the broadcast or connect you in some of these dialogues that we'll be having in the future with folks like my friend Wei Lam.
Thanks, Marcy.
Thanks. Thanks, everybody. Bye.